Hey everyone, and welcome back to the channel. Today we are tackling a classic interview question that is super practical. The meeting rooms problem. Leetcode 252. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. Imagine you are a busy person with a packed schedule. You have a list of meetings given as an array of intervals, each with a start and end time. And the big question is, can you attend all meetings without any conflicts? Let's look at a quick example to make this crystal clear. Here we have three meetings. Meeting 1 starts at time 0 and ends at time 30. Meeting 2 starts at 5 and ends at 10. And here we see a conflict. As this meeting 2 has started even before meeting 1 has ended, and we can't be in two places at once, right? So, in this case, the answer would be false. Now consider this example. Here, meeting 1 starts at 5 and ends at 8, and meeting 2 starts at 9 and ends at 15. This is good as meeting 2 starts after meeting 1, so we can attend all meetings, and hence the answer would be true. Also, note that instead of 9, if we had 8, the answer wouldn't change, as we can still start a new meeting just after the first meeting ends. Now, in terms of solution, a simple brute force approach is to compare every meeting with every other meeting. So, we would start by picking the first meeting and check it for conflict against all the other meetings one by one. And in practice, if you take any two meetings, let's call them A and B, we can imagine a few scenarios. One scenario can be that meeting A could finish completely before B starts, or meeting B could finish completely before A starts. In those cases, we will have no conflicts. But in other scenarios, we do get an overlap, and the core issue is always the same. One meeting starts before the other one has ended. So, for any two meetings A and B, they conflict if A's start time is before B's end time and B's start time is before A's end time. And the moment we find even one such overlap, we can stop immediately and return false, as it is impossible to attend both the meetings. So here, for example, meeting for interval 0:30 has conflict with meeting with interval 5:10, as the second meeting starts even before meeting 1 has ended. So we return false. But if we wouldn't have had the conflict, then we would have continued checking this first meeting with the rest of the meetings. Next, we take the second meeting and compare it against all the remaining meetings, then the third, the fourth, and so on. And we repeat this process, checking every unique pair. This approach works, but it is slow. For n meetings, we compare the first meeting to n-1 others, the second to n-2, and so on. This results in roughly n into n comparisons, giving us a time complexity of O of n square. But do we really need to check all the pairs? For example, suppose we have these meeting intervals, and here we can see that this meeting doesn't have a conflict with meeting 1. Then, do we need to check if the meeting 3 has a conflict with meeting 1? That will be the redundant work, right? Because if meeting 2 doesn't have a conflict with meeting 1, then all the meetings on its right won't have any conflict as well. And visually, we can see that these intervals have some sort of order. So programmatically, let's sort these intervals by their start times. And then this problem simplifies dramatically. Since we are attending the meeting in the order they begin, we only need to make sure that each new meeting we attend doesn't start before the previous one has finished. For example, if we have three sorted meetings, like these ones, let's label them A, B, and C. If A ends before B, we are good. When we check for C, we only need to ensure that B ends before C. This eliminates the need to check whether A ends before C or not. So, we don't need to compare a meeting with all the previous meetings, but just the one immediately before it in the sorted list. let's quickly look at some more examples. First, let's look at this non-conflicting example. Here, first we sort the list by the start times, and then we start at the second meeting and compare it with the previous one. And here we check the end time of the previous meeting, which is 4, is less than the start time of the current meeting, which is 7. So there is no conflict or overlap. And now, since we have reached the end of our list and we haven't found any conflict, we return true. Now let's look at this example. Again, let's first sort the array, but in this case, the array is already sorted by the start times. And we start at the second meeting and we compare its start time 5 with the end time of the previous meeting, which is 30. And here we see that 5 is less than 30. That means we have found an overlap and hence we immediately stop and return false. Now, the time complexity of this approach is O of n log n, dominated by the sorting step, because first we sort the array, which takes O of n log n time, and then we do a linear scan and compare each meeting with the previous one. That takes O of n time. So, because of this, the overall time complexity is O of n log n, and the space complexity will be O of 1 if we sort in place, or O of n if we are using some sorting algorithm which requires extra space. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on the left and Python on right. First, we sort the intervals array. In Java, we use arrays.sort with a custom comparator that looks at the start time, which is the first element of each subarray. And in Python, we use sort method with a key lambda function that does the same thing. After sorting, we loop through the intervals, starting from the second meeting at index 1. Inside the loop, we first grab the current meeting and the previous meeting from our sorted list. Then we have our one and only condition. We check if the start time of the current meeting is less than the end time of the previous meeting. If yes, then it means the current meeting starts before the previous one has finished and we have found an overlap. So we immediately return false. Otherwise, if the loop completes without finding any overlaps, it means our schedule is clear. We exit the loop and return true. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.